All right, so we are talking about absolute value equations and inequalities today. So the absolute value of a number is the distance from zero on a number line, and we talked about this in class last time and how those absolute value bars will always push out a positive number. So if we have the absolute value of 5, that's going to give us a 5. If we have the absolute value of -5, it also will give us the number 5. Because if we think about this on the number line, 2, 3, 4, 5, 1, 2, 3, 4, 5, absolute value is actually measuring the distance from 0. So how far is it from here over to here, or from here over to here? Well, distance is always a positive amount. Even if you run backwards, you still can't run a negative distance. So that's how absolute value works. So if we have the absolute value of x equals 5, that means that what values of x could we plug in here and still have a distance of 5? So you're always going to end up with 2 solutions. All right, so let's look at the rules right here. First thing it says to do is isolate the absolute value bars. So these are my absolute value bars. I want to get those by themselves, meaning I need to get this +4 to the other side. So that's how I'm going to start off. I'm going to subtract 4 from both sides. That leaves me with 2 equals the absolute value of x. We don't normally write x on the left-hand side, so I'm just going to rewrite this up here and have the absolute value of x equals 2. All right, once my absolute value bars are by themselves, step 2 says that if the absolute value bars equal a negative number, then there's no solution. So I always want to check to see, once these absolute value bars are by themselves, if this is positive or negative. If it's positive, we keep solving. If it's negative, we write no solution. So this is a positive, so I'm going to split this into 2 separate equations. So this says I take here, step 3 says I'm going to take what's inside of those bars and set it equal to the positive answer. Then I'm also going to take what's inside those bars and I'm going to set it equal to the negative answer. So here I'm going to have one side that's equal to +2 and one equation that's equal to -2. Oh, there we go. Sorry. All right, so that means that this would be x equals 2 and x equals -2. So these are my 2 solutions. All right, let's try that again. So for B, it says, what is the value of x in this equation? So we have the absolute value of 2x minus 5 equals 3. And step 1 says to get those absolute value bars by themselves. And that is by itself. There's nothing else on this side of that equal sign other than those bars. So we're ready to solve. So we're going to take this and split it into 2 equations. One equation is going to get set equal to that +3 that we have right there, and the other side is going to get set equal to a -3. So inside is 2x minus 5 equals 3. 2x minus 5 equals -3. And then we just solve like normal. So I'm going to start off by adding 5 to both sides. I end up with 2x equals 8. To get this x by itself, I need to divide both sides by 2. And I end up with x equals 4 as my first solution. Next, I'm going to go to this other equation, 2x minus 5 equals -3. Starting off the same way, adding 5 to both sides. I get 2x equals 2. And then I'm going to divide both sides by 2. And I get that x equals 1. That is my second equation. All right, moving to the inside. All right, for C, it says, what is the value of x in this equation? So first step says to get those absolute value bars all by themselves, which means I need to get that 7 out of there, and I need to get this 2 out of here. So I'm going to start with the 7. I'm going to subtract 7 from both sides. I end up with 2 times the absolute value of x plus 9 equals -4. All right. Are the absolute value bars by themselves? No, I still have this 2 over here, so I need to get rid of that. So one of the things that we want to make sure that we never, ever, ever do is we never distribute into the absolute value bars. And I'm going to abbreviate absolute value like that. So it kind of looks like what I'm talking about. So I never want to distribute this 2 in, like if it was a parentheses. To get rid of this, I'm going to divide both sides by 2. All right, that leaves me with the absolute value of x plus 9 equals negative 2. All right, now my absolute value is by itself. I check to make sure, oh, it's equal to a negative. Okay, so that means that we have no solution because, and this is like a little red flag here, our absolute values cannot equal a negative. When it does equal a negative, it is no solution. All right, on to the next problem. It says, what is the value of x? And then we have 3 times the absolute value of 1/2 x plus 7 minus 8 equals 4. So again, getting these absolute value bars by themselves is the first task. So I'm going to add 8 to both sides. That's going to leave me with 3 times the absolute value of 1/2 x plus 7 equals 12. All right, remember, we never, ever, ever distribute into the absolute value bars. So in order for us to get rid of that 3, we are going to divide both sides by 3. That way they cancel out. And I am left with the absolute value of 1/2 x plus 7 equals 4. All right, absolute value is by itself. I want to check and make sure that that is a positive number. If it's negative, like it was in the last example, it's no solution, but it's positive, so I'm going to go ahead and separate these out into 2 equations. So I have, let's see, I'm going to have one that gets set equal to positive 4 and another equation that gets set equal to that negative 4. So let's write these out so we can solve them. So 1/2 x plus 7 equals 4, and then we have 1/2 x plus 7 equals negative 4. All right, when we solve, so starting off, I'm going to subtract 7 from both sides. 1/2 x equals negative 3. And it's okay that we have a negative now because our absolute value bars are gone. So from here, I'm going to multiply both sides by 2. That way that fraction cancels out, and x equals negative 6. On the other side, same thing. I'm going to subtract 7. I end up with 1/2 x equals negative 11. And then to get rid of this 1/2, I multiply both sides by 2, and x equals negative 22. All right, those are our absolute value equations because they had equal sign. Now we're going to look and see what happens when we have problems where we have less than or equal to symbols. So rules are pretty similar. We still want to isolate the absolute value bars. We still want to check once they are by themselves if we have a negative number, and then we have a couple of options there if that happens. And then we will solve. So let's kind of dive in. It's always easier when we work through examples than just read the instructions. All right, so here, the same thing is happening. I want to get these absolute value bars by themselves, which it already is. So I am ready to separate into 2 separate equations. So one equation is going to be just like we did on the other side, where that symbol, that inequality symbol stays the same, and we have a positive 4. And then our second equation, our inequality symbol is going to flip in the other direction and be a negative 4. All right, so let's write this out. So we've got what's inside the absolute value bars. So x is less than 4. And then we also have x is greater than negative 4. So now we're going to put this onto the number line. So I'm going to have a point at 4. And I'm going to leave it open for right now, and then a point at -4, because I have to check to see if these are open or closed circles on the number line. So these are just less than and greater than symbols, so it says that we leave that as an open circle. All right, now we've got to figure out where we are shading. So if we want x values that are less than 4, we want to shade, use a pencil, this way. If we have x values that are greater than -4, we are shading that way. So we are going to use all of the numbers that follow both of those rules, which is all of this stuff in here. Any of these x values right here are going to work and be true for this solution. So when we write out our final answer, we are going to say that x has to be less than 4 and x has to be greater than -4. And yes, if you are wondering, you do have to write the word and, because it does make a difference. All right, let's try again. Here we have the absolute value of x that's greater than 4. So those absolute value bars are by themselves. So we're going to go ahead and split. So we're going to have one side that is going to keep the symbol the same, have that positive number, and then the other equation is going to flip the symbol and get that -4. So we get x is greater than 4 and x is less than -4. So we're ready to put points on the graph. So we have a point at 4. It is going to be an open circle, and another one at -4, also open circle. All right, so on these, I want x values that are greater than 4. So that means I'm going to be shading this direction because I want all the x values bigger than 4. And then here, I want all the x values that are less than -4. So I want all of these numbers until I get to -infinity or positive infinity. It just basically means that I can't use anything in between these two. All right, so when they point in opposite directions, we want to write our answer with an or in between. And I kind of think about it like, hey, I want to go that way, or I can go that way. All right, another example here is C. We have 3 times the absolute value of 2x plus 1 plus 5 is greater than or equal to 32. So, step 1, get these absolute value bars by themselves. So let's subtract 5 from both sides. That leaves me with 3 times the absolute value of 2x plus 1 is greater than or equal to 27. Now, I never ever distribute in to the absolute value bars. I always divide by whatever this number is out front. This time it's a 3. So that is going to leave me with the absolute value of 2x plus 1 is greater than or equal to 9. From here, I'm going to split the equations because my absolute value bars are by themselves, and this is a positive number. So we have one equation, we have a second equation. One gets to keep the symbol exactly the same with that positive 9, and the other one, I've got to flip that symbol with a -9. All right, so 2x plus 1 is greater than or equal to 9, and 2x plus 1 is less than or equal to -9. So first thing I'm going to do is subtract 1 from both sides. So if I subtract 1 from 9, that's going to give me 2x is greater than or equal to 8. And then I'm going to divide both sides by 2. I'm kind of running out of space here. So this becomes x is greater than or equal to 4. So there's one of my answers. And then over here is going to be my other answer. And I probably shouldn't have boxed that in just yet. I got a little ahead of myself. All right. The other one is going to be subtracting 1 from both sides. So 2x is less than or equal to -10. And then if I divide both sides by 2, x is less than or equal to -5. So I'm going to write these up here and figure out what do I put in between them based off where I'm shading. Is it going to be an or? Is it going to be an and? So these points both have the equal to underneath their inequality symbol, which means I need to fill that circle in. So we're going to have a solid point at 5 and a solid point at -5. All All right. This point, or let's start with this one. So x is greater than 4, so that means I want all of these numbers going that way. And I want x's that are less than or equal to -5. So I want all the numbers less than, so smaller, going this way. And it does not matter to me if you shade here like this or if you shade here like this. As long as you include these arrows at the ends so that I know that you're continuing your shading forever. All right, so these are pointed in this way or that way, so that means I write or in between my two answers. All right, last one, almost done. Okay, so same rules. Get those absolute value bars by themselves, so that means I need to get rid of the 6. I'm going to add 6 to both sides. I've got the absolute value of 4 minus 2x is less than or equal to 8. All right, absolute values of bars are by themselves. We're going to check that and then make sure it's a positive number, and it is, so we are ready to split into two equations. So on one side, we leave the inequality symbol alone with that positive number, and on the other side, we flip it, and we get a negative. All right, so 4 minus 2x is less than or equal to 8, and 4 minus 2x is greater than or equal to -8. Okay, so same process here. I'm going to subtract 4. I have a -2x is less than or equal to 4. And then I need to divide both sides by a -2. Now, something kind of crazy happens when we divide by a -2. So if you divide by a negative, you flip the symbol. So when I rewrite this here, I'm going to have to flip that symbol. So that's going to become x, and instead of it being a less than symbol, it is flipping to a greater than symbol. So you see how we flipped here and here? All right, so there's one solution. And then we are going to move to the other inequality. So same process, subtracting 4. We get -2x is greater than or equal to -12. And then again, it's going to happen. I'm going to divide by -2. Which means that I need to flip that inequality symbol. So x is less than or equal to 6. And you can see here the inequality symbol flipped because of that negative that I was dividing by. All right, so let's put these on the graph and we can be done with notes. So this is going to get a solid circle or a point at -2 and then a solid at 6. Oh, and I'm going to have to add 6 to my number line. All right, so this says I want x's that are greater than -2, so I'm going this way, and then x's that are less than 6, so I'm going this way, so they're going to meet in the middle here, so I'm going to use all of these numbers in between. So that means I want x's that are greater than -2 and x's that are less than -6. It's got to follow both rules so that it fits within this little parameter. All right, good job.